Warning. Although this video is school appropriate, some viewers may still find the following footage hysterical. Viewer discretion is advised. Out of the entire periodic table, which element do you think I'll be going over? I'll give you a hint.
F is for fire that burns down the whole town, used for uranium bombs. N is for no survivors when you
Light gun.
Now what is the element? If you guessed
uranium!
then you are indeed correct. My name is Harun Ahmed and I'm going to present to you the element uranium. The element uranium is a silvery, shiny metal that is both ductile and malleable. When something is ductile, it means capable of being drawn into thin wires. Something that is malleable means capable of being hammered into thin sheets. Beside plankton's bombs, of course, uranium surprisingly has many uses. Uranium is a crucial source for producing nuclear fuel. Uranium provides us with nuclear fuel used to generate electricity. A website that goes by the name of worldnuclear.org says that the nuclear fuel cycle is the series of industrial processes which involve the production of electricity from uranium in nuclear power reactors. The EPA, or the Environmental Protection Agency, says nuclear power accounts for 20% of electricity in the US. 1/5 of the entire nation's electricity is undoubtedly plenty of electricity, but that doesn't seem far-fetched given that uranium is about 40 times more common than silver and can be found practically anywhere in the world. As uranium is used for nuclear fuel, it is highly reactive. Uranium is a naturally occurring radioactive element that has no stable isotope. According to livescience.com, uranium's nucleus is unstable, so the element is in constant state of decay, seeking a more stable arrangement, which explains uranium's radioactivity. As crazy as it sounds, humans ingest small amounts of uranium, but don't wet the bed just yet. The amount of uranium is estimated to be 1.5 micrograms. To put that into perspective, a microgram is 1/millionth of a regular gram, so you can imagine how small that is. Uranium is the 92nd element on the periodic table. It is the 4th element on the actinide series that appears below the main body of the periodic table. A uranium atom has 92 protons in red, 146 neutrons in blue, and 92 electrons in green, of which 6 are valence electrons, or the electrons in the outermost layer. The 3 subatomic particles are protons, neutrons, and electrons. Protons in the nucleus are identified from the atomic number, since the atomic number is always equal to the number of protons. The protons determine the element's identity. Electrons are in orbitals that surround the nucleus of an atom. The number of electrons are also equal to the atomic number, given that the atom has a neutral charge. The electrons determine its electrical charge. For example, if there are 4 electrons more than protons, the net charge of that ion is -4. The neutrons are calculated by subtracting the atomic mass with the atomic number. Of course, the amount of neutrons can vary from different isotopes. The most common isotopes in natural uranium are uranium-238 and uranium-235. All elements with atomic numbers greater than 83 are radioisotopes, meaning that these elements have unstable nuclei and are radioactive. As atoms can bond chemically to form compounds, so can uranium. Uranium oxide is one compound that's also used for nuclear fuel. Uranium oxide is generally considered the preferred chemical form for storage or disposal. The chemical formula for uranium oxide is UO2, which means 1 uranium atom and 2 oxygen atoms. Another compound with uranium is uranium hexafluoride. Uranium hexafluoride is a compound used in uranium processing because its unique properties make it very convenient. The formula for uranium hexafluoride is UF6, which means 1 uranium atom and 6 fluorine atoms. What do you think the world would look like without uranium? If we really wanted uranium, we would have to manufacture it by nuclear reactions, probably from thorium. Otherwise, thorium, an element that shares similar properties with uranium, is the isotope of choice for development of atomic energy. Many elements and inventions that use uranium, such as plutonium, helium, francium, radon, and atomic bombs would go poof. The likelihood that radioactivity in general would be discovered, along with radioisotope production, is very slim. There you have it, a detailed overview of the 92nd element uranium. I genuinely hope you enjoyed the video, and if you want, like and subscribe to the channel if you want your teacher to give you 100% on the next project, and I'm out.